Hello and welcome to my Module 1 presentation. I'm Patricia Montgomery. So for our first question here, it says, draw a graph for each of the following scenarios and explain why the graph corresponds to that scenario. So below here, for A, it says the amount of gas in a gas tank when a driver refills the tank on a drive across the country. So for our graph here, for our y-axis, we have the amount of fuel in our gas tank. And for the x-axis, we have how far we've driven. So when you start your drive at 0 down here, you're going to have some amount of gas in that tank. Otherwise, you're not going to get anywhere. So we start here, but as we drive more and more miles, our gas is going to slowly go down. And when we stop to fill up that tank, it's going to shoot back up to one of those higher numbers up there. And then as we drive cross country again, it's just going to keep on going down. And then it'll repeat as you fill up and then stop and continue and all that. So for B here, it says the height of an elevator stopping at each floor on the way up. So just like when we stopped to get gas, we had that up shot. So now every time we stop on a floor with our elevator, we're going to have that shoot up and then that long wait time as people get off. And then up, and then we're going to slow back out. And so that's going to show on our graph there. And for C, we have the height of a bouncing ball dropping off of a table. So I feel like this one, when you think about a ball dropping and you watch it bounce up and down like that across the floor, that's exactly what our graph is going to look like. And it's going to start out and then it's going to slowly slow down as it loses that momentum. And then for D, it says the length of a shadow of a flagpole throughout the day. So if you know anything about the sun rotating in shadows, then you know that it's going to start out, and as the sun comes closer and closer and closer, it's going to get smaller, and then it's going to go back out and do that thing again on the other side. So our parabola is going to be equal with that point in the middle being when the sun is completely there. So for the next part here, we are going to see with these given functions that we have, and we're going to plug in our x values to see where this function is going to take us. So for our f of x function, it equals 3x. And for g of x, we have x plus 8. So our first value is 0. So we're going to plug that 0 into our f of x, and we get 0. So we plug that into the g, and then we're going to get g of f of 0 is 8. So then we're going to try 1. And we're going to do the same thing. We're going to start by plugging it into that f value. So 3 times 1 is 3, and then take that 3 and plug it into the next one. So 3 plus 8 is 11. So g of f of 1 is 11. And then for 2, we are going to get 14. And for 3, we're going to get 17. So for question 3, it says show and explain the slopes of line segments determined by the given parts. Also tell what direction the slope is heading. So our slope is going to be our rise over our run, which on a graph is going to be the y-axis and then over to the x-axis, whichever direction that may be. So for our first one, our points are P and Q, and we are going to use the slope function up here, this y2 minus y1 over x2 minus x1. And we're going to plug in those values, and we're going to get 4 over 2, or 2, which is going to be a positive slope. So if you want to keep looking at the 4 over 2 for the rise over run, so you're going to go up and then over, up and then over. So we're going in a positive direction. And that's what you can see with that line there. And then for part B, we're going to use R and S, plug those numbers in, and we get 0. So for 0, that means our slope's not changing. It's not going anywhere. It's just going to be straight up and down. And so then for C, we're going to use U and V, and we're going to get 3. However, if you look at our fraction, we had both of those negatives, so we're going in a negative direction, but at a positive rate. So question 4 says, show and explain the graph of each function and how they are similar or different from one another. So for y equals x2, we're going to have the origin is going to be at 0, because if you were to plug 0 in for x, you're going to end up with 0 for y. And so we're just going to have our parabola just facing normal. But then if you look at b, it's the exact same function, only you have a +7 at the end. So that's going to be our y-intercept. So that's going to show us that our new origin is going to be at 0, 7. So it's going to move up on that y-axis. And then for part C here, this is supposed to say -7. And so if it was going to be a -7, then we're going to go down. So basically, the only difference between them is that our y-intercept has changed, and therefore it's going to determine where that origin is placed on our graph. So question 5, we are going to show and explain the equation of a line through a given point that is perpendicular to a given line. So for it to be perpendicular to each other, it's going to be where two lines meet and form a 90-degree angle. And the way you do that is you look at your slope, and you take the slope and you find the reciprocal, which is the like flipped version basically. And so those two slopes are going to determine how those lines are going to intersect with each other. So for this first one, we have y equals -3/4 x plus 5 at the point R, which is 6, -1. So we're going to take that slope and we're going to flip it to the opposite, which would be 4/3. And we're going to use that and that point we were given and plug it back in. So it's going to read y minus -1 is equal to 4/3 x minus 6. And then once you distribute that 4/3 over to the x and to the 6, we're going to get our intercept, or our perpendicular line is going to be y minus 1 equals 4/3 x minus 34 or 24/3. So for the second one here, it looks a little different. We've got 2y plus 9x minus 5 equals 0. And then our point is S at 0, 3. So we have to solve for y here in order to figure out what our line is that we're even starting with. So to do that, we're going to take that 2y away from each side, and then we're going to divide by -2 to get that y by itself. And we're going to end up with y equals -9/2 x plus 5/2. So then we're going to take that end value, our slope, and we're going to flip it, and we get 2/9. So then we're going to do the same thing we did in the first one, and we're going to plug in that point that we were given with our new perpendicular slope, and we're going to do y minus 3 equals 2/9 x minus 0. So then we're going to distribute that 2/9 in again, and we're going to get y minus 3 equals 2/9 x, which is y is equal to 2/9 x plus 3. So in this red box here, I have both of those lines showing that are the perpendicular to those lines that we were given. So now we're at question 6, and we're going to learn about tangent lines and figure out how we find that for a tangent line of a circle. So for A, it says our radius is 9 at the point 0, -9. So we're going to use that down here in this green box. I've shown you the formula that you use in order to find that tangent line. And it tells us that A and B for this equation are our origin points, which we said that our origin points are 0, 0. So for A and B, they're both 0. And then for C and D, we're using that x and y of that point that we are given for each of these. So for this first one here, we're going to do y minus d, which as we look here is our y value. Our y value is -9, is equal to a minus c, which would be 0, minus our x, which is also 0, over d minus b, which is going to be our y again, which is -9, and 0. And we're going to multiply that by x minus c, which is our x again, which is also 0. And when you do that, you get y equals -9. And then for b here, we have the same thing, only instead of at -9, it's at +9. So we're going to go through and do the same thing, but we're going to pretty much just change all those -9s to a +9, which is actually going to give us y equals a +9. So for this last part, if we were to draw a circle with that center point being at the origin, and then you were to put that y equals 9 line up on there, and then y equals -9, it'll show you that those two tangent lines to that circle are actually parallel to one another. And that'll be all. Thank you.